Hello, my dear students. In the previous session, we have seen few problems on numerical aperture and acceptance angle. Now, we'll see another different types of problems on the same topic. So here, the fourth problem is calculate the numerical aperture and hence the acceptance angle. See, what is problem? Calculate the numerical aperture and hence the acceptance angle for an optical fiber given that the refractive indices of core and cladding are 1.45 and 1.40 respectively. So here, now what is given? Here they have mentioned the refractive indices of core and cladding. So here we'll write given data. So this will be the refractive index of core medium. It is denoted by mu1. So it will be 1.45, and then for second, that is a refractive index of cladding, that is a mu2. It is 1.40. So and then again we have to find out, first of all, it is numerical aperture. So it will be NA will be equal to question mark. And second one, we have to find out the acceptance angle, that is a theta naught. Again, see, we know the formulas for both of the unknown quantities. So here, the formula for Na, it will be what? Under root of mu1 square minus mu2 square. So this is the formula for numerical aperture. And second one, we know the formula for acceptance angle, that is a theta naught. See, here we will find out the numerical aperture. So for acceptance angle, we'll use the formula as sine inverse of numerical aperture. So that will be easy for us to find the solutions. So here the solution will be, first of all, for Na, again the formula is same, that is mu1 square minus mu2 square. Now we will substitute the values over here. So the value of mu1, it is 1.45 bracket square minus 1.40 bracket square, and then by calculations here we can easily find out the value of numerical aperture as 0.3775. So this is the value of numerical aperture. Got it? Now again for second one, that is acceptance angle, we have the formula. So here the formula will be theta naught is equal to sine inverse of numerical aperture. So now we'll simply substitute the value. So here sine inverse of the value is 0.3775. So here the answer is, it will be 22.18. The value is what? 22.18. And the unit for acceptance angle will be a degree. So these are the two values for the numerical aperture. So this one is for Na, again this one, and this is for acceptance angle. So see, in this question it was quite simple because they have clearly mentioned the refractive indexes for both core and cladding, and we just have to find out the numerical aperture. And the second one is what? It is the acceptance angle. We know the formulas for both of them. We have simply substitute the values, and then by doing simple calculation we'll come to the final conclusion. So now this one is the fourth one. Now we'll go for the next one. So now we have next one. A fiber cable has an acceptance angle of 30 degrees and core index of a refractive index 1.4. Calculate the refractive index of cladding. This question was asked in December 2016 for 3 marks. So now we'll find out the values. So here, first of all, I'll write down the given quantities. So here given, what is given? See, they have mentioned the acceptance angle of 30 degree. So that means what? The value of theta naught is given, and that is 30 degree. Again, along with this, we have core index of refractive index. So that means the value of mu1 is given, and it is 1.4. And then simply we have to find out the value of refractive index of cladding. So that is a mu2 will be question mark. So again, see, now which formula we will use over here? See, as they have given the value of acceptance angle, and when we know that in the formula of acceptance angle, we have both the terms mu1 and mu2. So definitely we'll go for that formula. So the formula for acceptance angle is what? It is a theta naught equal to sine inverse of under root mu1 square minus mu2 square. So here we there are three quantities and we know two out of them. So we can easily find out the rest of the quantity. So here the solution will be like this. See, here I can make this equation as this will be sine theta naught is equal to under root mu1 square minus mu2 square, and then on squaring both sides we'll have sine square of theta naught is equal to mu1 square minus mu2 square, and then we can form the equation as here we have to find out mu2, so it will be mu2 square is equal to this one be mu1 square minus sine square theta naught. So now we can use this particular formula, or again we can write this formula as this will be mu2 equal to under root mu1 square minus sine square theta naught. So we'll use directly this formula here. So the here for solution it will be mu2 is equal to under root this is mu1 square minus sine square theta naught. Now we'll substitute the values over here. So now mu1, the value of mu1 is what? It is 1.4. So it will be 1.4 bracket square minus theta naught is 30. So it will be simply sine 30 and again that of the square. So here we can write this equation as again under root it will be 1.4 bracket square as it is. Now we know the value of sine 30, it is a 0.5 bracket square. Now by doing calculations, the value of mu2 it will be 1.308. So this is the value of a refractive index of cladding. This is what value of a refractive index of cladding. See again here, initially they have mentioned the acceptance angle as 30 degree, and then core index of a refractive index 1.4, and then we have to calculate the refractive index for cladding. Formulated this particular formula in the form of mu2, and then we simply substitute the given values over here, and then in the final we get the refractive index of cladding. So this was again another example. Now we'll go for the sixth one. So now here the next problem is compute the NA, that is a numerical aperture, acceptance angle, and the critical angle of fiber having a refractive index of core as 1.50 and that of the cladding is 1.45. So here they have given the values of a refractive indices for core and cladding, and then we have to find out the values of NA, that is numerical aperture, acceptance angle, and the critical angle. So here first of all we'll write the given quantities. Now we know the symbol for a refractive index of core, so it will be mu1 is equal to 1.50. Then we have the refractive index of cladding, so that will be mu2 and it is 1.45. Then we have to compute, that is we have to find out the values for NA, that is a numerical aperture, then acceptance angle, and the symbol is theta naught. And the final one, it is critical angle. The symbol for critical angle is a theta C. The symbol for critical angle is what? Theta C. Then again, we'll go for the formulas. So the formula will be what? First of all, for Na, see, they have mentioned the refractive indices for both. So we will use the formula for Na as under root mu1 square minus mu2 square. Then for theta naught, the formula will be simple. It is a sine inverse of Na. And then the third one, see, this is first one, this one is second one. Here again, we'll mark these two, and this is third one. So here for third one, that is the critical angle, we'll use the formula as theta c is equal to sine inverse of mu2 upon mu1. That is a refractive index of cladding divided by a refractive index of core medium. Now we'll go for the solution. So here for first, it will be for Na. So it will be Na is equal to under root mu1 square minus mu2 square. Now we will substitute the values over here. So for mu1 it is 1.50 bracket square minus for mu naught the value is what? 1.45 square. So by doing calculations we can find out the value of Na, and it will be 0.387. The value is what? 0.387. So this is the value of Na, that is numerical aperture. Now we'll go for the second one, that is acceptance angle, and then it will theta naught is equal to sine inverse of Na. So it's quite simple. It is sine inverse of 0.387, and the answer is 22. It is approximately 22 degree. So this is a theta naught. So here again we'll go for the third one. So it is what? It is critical angle. So it will be theta c is equal to sine inverse of this mu2 upon mu1. So by substituting the values here, mu2 is what? It is of cladding. So it will be 1.45 divided by 1.50. And then by doing the calculation, one can have the answer for critical angle as 75.2 degree. So see, these are the values which were asked in the problem. So here this is Na, this one. Then this is acceptance angle, that is theta naught, and the final, this is the critical angle which is required, or which is the main requirement for total internal reflection, and that is the working of optical fiber. So this was the question basically. Here I'll repeat again. See, this is the compute the Na, acceptance angle, and the critical angle of fiber having a refractive index of core, that is 1.5, and that is of cladding, it is 1.45. The values of mu1 and mu2 are given. We have to find out these three quantities. We know these straight away, the formulas for these three quantities, that is Na, then theta naught, and theta c, that is critical angle. And then by doing simple calculations, we'll come to the final result. Now, dear friends, we'll go for the next problem. So here the question is, calculate the refractive indices of the core and cladding material of a fiber from the following data. So we have to find out refractive indices for both core and cladding material, and they have mentioned the value of numerical aperture as 0.22 and that of a delta. So now this is a delta, and the value of delta is 0.012. Now we know what is meant by this delta. See, this delta is nothing but it is what? It is a relative refractive index, and then this Na is a numerical aperture. So here, first of all, we'll write the given quantities as Na is equal to 0.22, and this is the delta, that is a relative refractive index. It is a 0.012. We have these two values now, and now we have to find out the refractive index or refractive indices of core, that is a mu1 will be equal to question mark, and then another one is mu2, that is a refractive index of cladding. Now see, for this they have given the value of Na, that is numerical aperture, and the second one is what? It is delta. The delta is a relative refractive index. So now the formulas will be what? See, we know the value of Na. Now see, we have Na as, either we can take it as a sine theta naught, that is in terms of acceptance angle, or under root mu1 square minus mu2 square. But here mu1 and mu2 both are the unknown, so we can't use those first mentioned two formulas. So now we'll go for the third formula of numerical aperture, and that is mu1 into under root 2 into delta. So while discussing the mathematical expressions for numerical aperture, I have mentioned that we have to use all these formulas in the calculations or numerical solving. So here, this is the formula for numerical aperture as mu1 into under root 2 into delta. Now one can easily say that we know the value of Na and delta, so we can easily find out the value of mu1, that is a refractive index of core medium. And now for mu2, see, again we have the value of Na, so we can use the formula as, or see, we can use the formula of Na as under root mu1 square minus mu2 square. So now from this first equation, we will have the value of this mu1 here, and then we can easily substitute this mu1 into this second equation over here. We know the value of Na, so we can easily find out the value for mu2. Okay, so now the solution is what? It is here, it is solution. So first of all, we'll find Na. So Na is what? It is a mu1 into under root 2 into delta. We can write this formula as mu1 is equal to Na divided by under root 2 into delta. So now we'll substitute the values over here. The value of Na is what? It is 0.22 divided by under root 2 into delta. Delta is what? It is 0.012. And then we can easily find out the value of this mu1 as 1.42. So this is the value of mu1. Now we can substitute this value into the another formula of this numerical aperture as this mu1 square minus mu2 square. So here I'll directly make the changes into this particular formula, and then I can directly write this formula as a mu2 is equal to under root this mu1 square minus Na square. So we can easily write it down. Now we will substitute the values over here. The value of mu1 here we have find it out already. So it is 1.42 bracket square minus the value of Na, it is a 0.22. And then by doing calculations here we'll get the value of mu2, that is a refractive index of cladding material as 1.40. The value is what? 1.40. So here they have given the value of this Na and delta, that is the relative refractive index, and we have to find out the refractive indices for both core and cladding. By doing calculations, we have already found out the values. This is the mu1, that is the refractive index of core medium, and this is mu2, that is refractive index of cladding. I hope you understood the problems now. Now we'll go for the next one. So now take a look at the next problem. a glass clad fiber is made with core glass of a refractive index 1.5. So here they have mentioned the core, the refractive index of core, that is as 1.5, and then the cladding is doped to give a fractional index difference of 0.0005. So here they have mentioned to this particular word, fractional index difference. See, if you remember that while doing mathematical expressions, I have told you that what is index difference. Index difference means what? That is the difference between the refractive indices of core and cladding. But here the fractional index difference is what? It is nothing but a relative refractive index. So here the given quantities will be what? So here I'll write given first of all, and then we'll discuss what we have to find it out is. So here given they have mentioned the refractive index of core, so it will be mu1 is equal to 1.5, and then second quantity is delta. The fractional index difference is nothing but a relative refractive index, and that is a delta. So the value is 0.0005. And now we'll come to exactly what we have to find out is. See, first of all, we have to find the cladding index. So cladding index is nothing but here I'll write to find. So first of all, cladding index means what? It is a mu2. So mu2 will be equal to question mark. Then we'll go for the second one here. See, the second one is what? It is the numerical aperture. So that is again quite simple. It is NA. So NA is equal to question mark. Then we'll go for third one now. See, third one, the third quantity is what? The critical internal reflection angle. The critical internal reflection angle. See, if you remind of the working of SI, that is appendix fiber. See, when we explain the cone, the concept of cone, that was like this one. Suppose this is and this is axis, and then these are the rays like this one. So here this is what, this is the acceptance angle, that is theta naught, and they have mentioned the critical internal reflection angle. That means this angle. A reflection angle means this one, and we know that this is what, it has to be greater than theta c, that is critical angle. So in short, here we have to find out the value of critical angle. So this one, the third one is what? The critical internal reflection angle. It is nothing but critical angle. So it will be theta c. It will be what? Theta c. And then now come to the fourth quantity. It is what? The external critical acceptance angle. So no doubt it is nothing but the acceptance angle. So the fourth quantity will be theta naught, that is equal to question mark. Now we'll go for the solution one now. See, we know the given quantities and then we know what we have to find it out is. So here the solution will be, first of all we'll find out mu2. See, for to find out the mu2, here the formula will be what? Here I'll write as, first of all I'll write the formulas, and then we'll go for the solution. So here the formulae. So formula will be what? First of all, to find out mu2, see, they have mentioned mu1 as well as we know the value of delta. Now we know what is meant by delta. Delta is what? It is a fractional a refractive index. So here the formula will be what? It will be mu1 minus mu2 divided by mu1. So this is the formula for delta. So here from this formula we can easily find out the value of mu2. So we can easily find out the value of mu2. If I arrange this equation as, see, it will be delta mu1 will be equal to mu1 minus mu2, and then we know what will be the mu2 then. See, this delta mu1, it will be on this side, so it will be mu1 into bracket 1 minus delta. It will be what? 1 minus delta. And then we know the value of mu1, that is 1.5, and as well as we know the delta. So we can easily find out the value of mu2, that is a refractive index of cladding. Now for Na, again that is simple one. Na. Now here from this first equation we'll have the value of mu2. The mu1 is given. So here we'll use formula for Na as mu1 square minus mu2 square. Then for third one, that is the third one is what? Theta c. Theta c is nothing but critical angle, and we know the formula. It is what? Sine inverse of mu2 divided by mu1. And then at last we have to find out theta naught, and it is nothing but here we know the value of Na. So theta naught will be sine inverse of Na. So now we have all these four formulas. We just have to substitute the values. Then we'll come to the final solution. So here the first one is what? It is we have to find out mu2. So I'll take this formula, this one. See this formula. So here I'll write the formula first. So it will be mu2 equal to mu1 into bracket 1 minus delta. Now we will substitute the values over here. So this is 1 minus 0.0005, and then by doing the calculations, we'll get the value of mu2 as 1.49925. So this is what? This is the value of mu2, that is a refractive index of cladding material. So this one we have done with this. Then now we'll go for second one. It is what? Na. So the formula for Na is again quite simple. It is under root mu1 square minus mu2 square. So here the values will be mu1. The value of mu1 is what? It is 1.5 bracket square minus mu2. Here we have the value of mu2. It is 1.49925 bracket square, and then by doing calculations we'll get the value of Na as, see, the value is what? It is 0.0474. So this is the value of Na, that is numerical aperture. So here now we get the value of Na as well. So now we'll go for the next one, that is what? It is theta c. That means what? Critical angle. So here theta c, now it is the third one. This theta c, the formula is again same, sine inverse of mu2 divided by mu1. So we have to simply substitute the values over here. The value of mu2 is what? It is 1.49925 divided by mu1. It is 1.5. And then we'll get this theta c as, here I'll write this theta c, that is critical angle, as by calculations we'll get the value as 88.2 degrees. So this is what? This is critical angle. And then finally we'll go for acceptance angle, that is theta naught, and the formula is simple. It is sine inverse of Na, that is numerical aperture. So it will be sine inverse of 0.0474, and then again by calculating the inverse of sine we'll get the value for theta naught as 2.720. So this is what? This is the critical angle. Again it will be in a degree. So these are the what? These are the values of required quantities. So here the question was quite simple. The main thing, like see in question, just remember these two words. The first one is this one, fractional index difference. That is nothing but it is what? Delta. That is a relative refractive index. And then we have to find out this cladding index means mu2. Numerical aperture is quite simple, but this C and D. So critical internal reflection angle means definitely go for theta c, that is critical angle. And when they ask the external acceptance angle or the external critical acceptance angle, that means we have to find out the theta naught, that is simply acceptance angle. So this was the for the question, and then we have found out the values for this mu2. Then this numerical aperture, this is mu2. Here this is theta c, that is critical angle, and finally we have acceptance angle. So my dear friends, I hope you understood all the problems that we have discussed in this particular session. Now, in the next session, we'll go through some basic formulas again, basic numericals, quite different one, as well as we'll see the difference between SI and graded index fiber. So step index and graded just in tabular form. So see you in next session. Thank you so much.